Okay, number 4 from section 4.7. It says, let A be this collection of basis elements. Let B be this collection of basis elements for some vector space V. And suppose that you can express the B basis elements in terms of the A basis elements like this. These are all bold-faced letters, by the way, because they're column vectors, okay? And part A says, find the change of coordinates matrix from B to A. And you know, we did something with a change of coordinates matrix already, but if you recall, it was something like this. We said, well, the change of coordinates matrix with respect to B satisfies this equation. It will take coordinate vectors with respect to basis B into regular vector form. So this is the equation that we talked about before. But the change of coordinates matrix we're going to do now is just a little bit different. The key equation in this section is the following equation. If you want to go from basis, and I guess I'll use the same letters in this problem, we want to go from B to A, then you essentially want to find a matrix that will satisfy this equation. So here's the notation for the change of coordinates matrix from basis B to basis A. But it essentially just takes coordinate vectors with respect to basis B and changes them into coordinate vectors with respect to basis A. All right, so that's what this is in this section. So it's a little bit different of a change of coordinates matrix, but very similar equation. Okay, but here basically is how you do it. How do you find this thing? Well, you can show, and you can kind of verify it for yourself if you like, that this matrix is of the following form. You basically just have to take all of the basis elements in B, and I guess in this case it would be B1, B2, and B3, and just make the columns of that matrix the coordinate vectors with respect to basis A, or whichever basis you're going into. In this case, it's A. So that's a column, the first column of this change of coordinates matrix. This is the second column, and this is the third column. You can kind of verify for yourself if you like that that will actually do what it's supposed to do. It's actually a little bit easier to see why this is true if you do a simpler example like number 1. But I wanted to do something just a little bit harder. Okay, so here's kind of the key equation you use in most of this section is right here. And you just have to remember that when you want to come up with this change of coordinates matrix, you just have to take all the elements in this basis and come up with their coordinate vectors with respect to the new basis and make those the columns of your change of coordinates matrix. Okay? And that's essentially what they're asking us for. So let's see if we can do it. Okay, so we really just want basis B1 with respect to the coordinate vector of that with respect to basis A. Well, that's easy. It's given to us. It's right there. So it looks like it would just be 4, 0, negative 4. Those are just the coefficients of the A bases. Okay? And this is vector B2, at least the coefficients with respect to bases A, the A bases, which are negative 1, 3, 0. And the last one is B3. That's just 1, 1, 5. Okay, so that's the first problem, the first part. So it's really kind of a neat little equation because you can go from the coordinate vector in one basis to the coordinate vector of another basis just by looking to see what happens to the basis elements. And that kind of sounds familiar, doesn't it? Go back to the beginning of the course. All right. Now, let's do part B. Part B of that problem says find the coordinate vector of x with respect to basis A when x is written like this. Okay, so notice that x is given to you in terms of basis B. So they've essentially given us this right here. So we just want to find this. Okay. Now I know they gave it to us just as a not as a coordinate vector, but we can easily change it into a coordinate vector, right? Because by definition, those are just the coordinates of the B basis elements, which are 1, -5, 5. Now I'll just plug it back into that equation up there. So we're looking for the coordinate vector of x with respect to basis A. That's going to be equal to that matrix we just found. Times that vector. Easy. So we'll just do the calculation. And you should get this. All right, so that is the coordinate vector of x with respect to basis A. So kind of a nice little trick. And just about every problem in the section involves that equation.